next, we're pleased to have a talk called NSF Vision for Smart Service Systems Research. And we have Dr. Pramod Khargonekar as our speaker. I hope we've pronounced your name correctly, more or less. And basically, he was appointed to the NSF to serve as Assistant Director for the Directorate of Engineering last year. And in that position, he leads the Engineering Directorate with an annual budget of $800 million. And you can read his very impressive resume and bio in our handouts. And he has lots of accomplishments, and particularly in this new area of the new institute that's being formed. It's a combination of what, let's say, what ESD MIT does and LID's Information Decision Systems. And basically, he's going to talk about this NSF New Vision for Smart Service Systems Research. Welcome.
Well, good morning, everybody. Thank you, Professor Larson, for that introduction. It's a great pleasure to be here. I'm sorry I wasn't here yesterday. It looks like I missed a lot of interesting discussions and so forth, but it was unavoidable. What I thought I would do, and since I missed yesterday, so I'm not completely sure that what I'm going to talk about is completely matched to what happened yesterday, but I think from what I just heard, I think it's pretty well matched. I'm going to offer some perspective and thoughts from my vantage point in the area of service systems. But I think it's a great place to begin, since I'm at MIT, talk about a quote from Chuck West, your former president. And actually, there's an interesting connection between this and my own career. Chuck West was the Dean of Engineering at Michigan when I was offered a job at University of Michigan. And by the time I got there, he became provost. And within a couple of years, he came to MIT as president of MIT, and then he was president of the National Academy. I think this kind of captures a lot of wisdom. I don't want to read this out, but it sort of essentially is sort of a guiding philosophy, guiding vision for a lot of the way we are thinking and a lot of the way perhaps you are thinking. Our job at NSF is in some ways very difficult and in some ways very simple. Particularly my job is very simple. My job is to make the wisest possible investments of public tax dollars for societal benefits by investing in engineering research, in education, and innovation. And that's what we try to do. And we look to this particular area as a potential area to invest in for great societal benefits, as you will see why that might be possible. Service economy. Just a few facts. The US service sector is responsible for 80% of workers and more than 80% of GDP. Manufacturing, which is, of course, a very important component, especially from engineering standpoint, is less than 11% in employment now. In the future, we are going to need high-quality, low-cost, personalized solutions in a whole host of areas, and you already heard some of them: education, healthcare, transportation, agriculture, and so forth. There are three pieces on this chart, maybe hard to see from the back, so I'll just try to make the story very simple. I'm not an economist by training, but I think the charts and the data are quite compelling. economic growth is largely a function of two variables: how many people you have and what's their productivity. In developed as well as developing economies, it's increasingly the case that it's the labor productivity that is going to be the much bigger component of economic growth. It's certainly true for developed world. It's increasingly true for parts of the developing world. It's not the case. I mean, it's certainly true that there are still a lot more people that need to come into the mainstream global economy, but it's labor productivity that is going to drive the increase in standard of living worldwide. Now, we have enjoyed amazing progress in labor productivity, especially if you go back to the dawn of industrial revolution. So if you go back to that time, the progress is absolutely fantastic. What has become increasingly clear that since about 1970, or a little past 1970, that productivity growth has slowed very significantly. It's down to about 1% now. There was a little blip in the 96 to 2004 timeframe, and it's, however, back to below 1%, around 1.5%. The bottom left chart is from a paper in New England Journal of Medicine, which broke down labor productivity data for different sectors, including manufacturing and services. And what really stands out is that in the healthcare space, the productivity growth is actually negative. Now, I say this with a lot of caveats. Again, I'm not an expert in this business, but it's difficult to measure these things. And do you really want to measure only productivity? How about quality? And so on and so forth. So it's a much more complex picture than I'm stating. Nevertheless, sort of at 10,000 feet level, the trends are very, very clear. That whereas in manufacturing, the productivity has remained high, in service sector, it has remained very low. And there is a wonderful quote from Robert Gordon, an economist at Northwestern, who makes the point in a very, very compelling manner. Manufacturing is performing a magnificent ballet on a shrinking stage. And that's the challenge that I think we need to take on, especially in the developed world, but possibly in the developing world as well. I.e., if productivity, quality, and so forth in the service sector doesn't improve significantly, then probability of increasing standard of living of people worldwide and people in the United States is not that great. And so now service is a very large term. When I came in, I talked to Manzar, and it's very complicated, and I totally agree that it covers a lot. This picture you may have seen yesterday either with Sally or Grace, when they talked about it, the picture is not that dissimilar from what Manzar showed us in terms of what they are thinking, except that I put all of the human stuff into one box. So really, people, by people, you really want to think about people as individuals, people as institutions, people as regulatory bodies, people as different forms of organizations, i.e. people act as individuals, but also act as parts of groups and with different identities, as a matter of fact. And so if you think from that point of view, then you can conceptually think of a service system as something that involves human interactions in their various forms with physical and informational environments to add value a la Chuck West. So that's one sort of working, you can think of it as a working definition, not a very formal definition, but it allows you to think. Now, on this piece, mediated by advanced technologies, well, there is a tremendous case made for advanced technologies in the recent book by Brynjolfsson and McAfee called The Second Machine Age. In case I suspect a lot of you have seen it. In case you have not, the thesis of the book is relatively straightforward, which ties back into my earlier story. So the story so far was Industrial Revolution that truly transformed the fate of humanity was driven by exploitation of mechanical power. So prior to that, we were limited by our muscle power. And we could use horses and bullocks and so forth, but really it was steam engine and so forth that allowed us to harness the power, the energy that was in fossil fuels and other things, leading to this great progress in all parts of our endeavors. We are on the brink of a second machine age where it's going to be our brain power, our cognitive powers that are going to be transformed by the rise of things like machine learning and robotics and smart systems and so on and so forth. So the technology piece of that smart service system is either here or will be coming at us very, very quickly. At NSF, we are certainly doing a lot of things in this direction. So I'll talk first about things where we have much better formulations, much better ideas about what we want to do than areas where we are looking for ideas from the community. So advanced manufacturing is a major priority for the president and for NSF, and actually it enjoys bipartisan support on both sides of the aisle on Capitol Hill. So this is one of those great areas where everybody loves it. And we certainly are investing in this space, particularly from this cyber manufacturing angle. And this blurring of lines between service and manufacturing really is a driving feature of what's going on with the rise of Internet of Things and so forth. I think there is going to be, it's clear that this space is going to get transformed with 3D printing, distributed manufacturing, maker spaces. I mean, there's a whole host of things going on that this we will see changing in the next 10 to 15 years in ways that I think is becoming clear. Second area where things are increasingly clear, this is much bigger part of the service sector, is the retail. I mean, retail, going back to Walmart and now to Amazon, is truly transforming itself. And again, you see engineering thinking getting in at, really at the gut level of a company like Amazon. This is the story out of McKinsey. When Toyota met e-commerce, lean at Amazon. And just a little quote from that story, you can go and read the whole thing for yourself. But it seems as if we will see clearly the insertion of engineering into retail, and that is going to happen, and again, truly transformative changes are already here and will continue. What I will now transition to are things where things are not nearly as clear, but offer equally big, if not bigger, challenges and opportunities. So essentially, our thinking here is driven by this emerging cyber-physical social future that was touched upon earlier, where we have our environment, our work, our life, our homes, et cetera, infused with sensors, control, computation, networks, et cetera, et cetera. And what we are thinking is, can we build upon that to add value to the service system that I talked about? And so some of the research challenges we see from that point of view are much increased complexity, range of scales. On the one hand, you have global scale connectivity and networking to highly personalized solutions, which is what is really needed to make significant impacts. Much faster time scales, almost real time, or certainly rapid response. We surely want these systems to be to learn, to be intelligent in a certain sense, not very formal, but certainly in the sense of learning from experience, learning from data, and so forth. And most importantly, we want these to be human-centered, because none of this makes any sense if that doesn't account for the fact that it's all about people in their myriad identities. So with that background, or with that sort of the questions that we pose ourselves are, what fundamental knowledge is needed, and what research communities need to be at the table to create that knowledge. To shed some light on these questions, I thought I would offer you a thought experiment. So this goes back to 1801. This is, as I understand, the first rail engine that was created in 1801. So imagine you are in 1800 or 1799, and you are seeing this budding railroad industry coming about, and you are out there building this engine. Well, I think from everything I know, there was no such thing as a field of mechanical engineering at the time. Certainly not the systematic mechanical engineering that we know of today. And so the question that we think of is, are we in an analogous situation with respect to service systems? That is, we are building this stuff, but we don't have the foundational knowledge that is systematized to the extent that we see in this analogy. Of course, 200 years have passed. Although it did take 200 years to build the field of mechanical engineering. It came much faster than that. Nevertheless, could it be that we are in a situation where we are building these systems, seat of pants, because there is a financial, there is an economic opportunity, but we don't have the foundational knowledge, certainly not codified in a way that we can teach and go after this systematically. And then the question that I would pose in this regard is, what might we learn from experiences in development of new engineering fields? And two examples that come to mind are material science and more recently biological engineering. These fields have literally come into being in the last 50 years, and we might learn something from them. And particularly biological engineering could be a much closer analogy to the kind of foundational knowledge that we might need. So in that spirit, the kind of questions that we might pose ourselves are with respect to models, because as we know in engineering, models are absolutely the fundamental building blocks. And traditionally, we have leveraged knowledge in chemistry, physics, biology, and certainly the tremendous power of mathematics to bring those models to real life. So the question that we would like to pose is, what might constitute models as we think about engineering for these service systems? What are the right kind of models? What's the right kind of mathematics that goes with those models? And clearly, the question then would be, what would be the role of social and behavioral sciences in this regard? Because any model here must leverage the knowledge in social and behavioral sciences for it to make any sense. However, what I would argue is that we shouldn't be too presumptuous about the nature of those models, nor should we be hidebound by our past experience in engineering in terms of the type of models and the type of tools that might be useful. And the second piece of foundational knowledge would be analysis and design tools. So you have models, and then you have analysis and design tools. So a series of questions that all are relatively straightforward. What kind of tools might be developed to systematize the process of engineering service systems? How do we leverage recent advances in cyber-physical systems as well as in machine learning? Clearly, cybersecurity is going to play a big role in this world, especially if you start interacting with humans. Already in Internet of Things, people worry about all sorts of dire scenarios. So those are the harder question in my mind is, how would we put people in the center of framing design questions? To me, that's sort of the hardest thing to get at is, yeah, we say it's all about humans, it's all about organizations, it's all about institutions, it's all about individuals. And here it sort of very quickly borders into economics and social sciences and organization theory and very quickly into regulatory and policy issues. So those are all the questions that we would need to think about. And if we miss that one, I think we will have missed the boat. And what might we learn from recent experience, early experiences in infrastructure and in retail? So I want to now quickly go over two examples where things are, I think, a lot more murky than the ones that I've talked about. And first is learning and education. So I don't have the data in front of me, but certainly there is such data out there that the productivity of a teacher hasn't improved significantly in decades. And again, it goes back to the early data that I presented. At the same time, we face tremendous challenges in K through 16 education. I mean, that would be a topic of a workshop all by itself. There is a growing body of knowledge in science of learning and education, partly NSF funded. And then we have the tools, the kind of thing that Manzar said. We have the data, we have the tools, we know a lot more about what's happening. There was a workshop held at NSF sometime last year, and there was a talk by a professor from Carnegie Mellon who has since moved to Stanford, and I don't remember for the life of me her name. But on her slide, there was this idea that what we need is a new kind of expertise called learning engineers. And so the idea, so the proposition was, can we create a new discipline called learning engineering, which was intended to translate fundamental insights on science of learning into new environments and tools. So there was a glimpse of something that is coming not from a group of engineers, but it's coming from people in behavioral sciences saying, hey, we know this stuff, can we turn this into useful? So the idea of a learning engineer, just like we have automotive engineers and we have aerospace engineers, could one imagine a future, 20 years, well, maybe it shouldn't take that long, 20 years where we have people we are called learning engineers, and they actually transform the delivery of education. Second, healthcare. And I'm sorry, I'm using healthcare, I should use health. Well, you know, this is again topic of probably workshops and you know, year-long activities. Just a couple of points. Aging is one of the major trends, certainly for the developed world and even for parts of developing world. And cost, quality, access, efficacy are major societal problems of our time. There is a recent report out of PCAST. I think it's 2014, if I remember right. Yeah, May 2014. Report to the president, better healthcare and lower costs, accelerating improvement through systems engineering. So it's a call for how do we use ideas from systems engineering to impact various parts of this so $4 trillion or $3 trillion business in the United States. And can one imagine health engineers, a la learning engineers on the previous slide? And this is from a paper by Newton and Larson, Clinical Medicine and Research, where they posit this idea of a learning healthcare system. A simple example to illustrate this one would be drug interactions. I mean, could we very quickly find about when you introduce new drugs, we know drug interactions happen. People taking a couple of combinations have very different effects than people who are not taking it. Well, a learning healthcare system would alert us to those types of things much more quickly than is happening now. So, the challenge here would be, would a sort of smart healthcare service system designed according to the kind of discussion we have had lead to a much faster learning cycle in the overall healthcare system, and with obvious impacts. Some of the relevant NSF programs to this way of thinking are, there's a bunch of them that we fund, and so clearly what we are looking for is something that builds on our investments in all these different directions in a new way, to create this foundational knowledge to make long-term impacts. Before I close, I want to go back to the Brynjolfsson-McAfee book, where they talk about these brilliant technologies, and there is a dark side to that brilliant technologies piece, which is, they in fact have it in their book as well, but it comes out very compellingly in a paper out of Oxford University in 2013, The Future of Employment, How Susceptible Are Jobs to Computerization. So what they do is they take all the BLS, Bureau of Labor Statistics produces all the job categories, and they break it down and look at the pieces that are amenable to automation, and say 47% of total US employment is at risk. A lot of it is in the service professions. A lot of them, it's already happening and is likely to happen more. This is where this idea of putting humans in the center of framing design questions is absolutely critical. If we don't do that, I think a lot of the dire future, I'm not a gloom doom type of person. I think we can manage our way through this to a much brighter future where people are actually much more productive and have much higher quality of life. I think this is possible, but it's not going to happen willy-nilly. It's going to happen only if we are very, very rigorous in our thinking and creative. So to conclude my presentation, just 3 ideas. Is there a real opportunity to lay the foundations of X engineering, where X could be learning, X could be health, X could be Pick your topic of interest. We would encourage us to be bold and creative, but be rigorous. Not rigorous in the sense that Dick mentioned, which is, journal publications. Yeah, of course, I'm a professor just like rest of you, and so, yeah, we do bow down to the demands of publications. But I think that I wouldn't say is our overarching constraint. Our overarching constraint is creation of that foundational knowledge. Is that knowledge trusted, and can it really be used to create value added? Going back to Chuck West's idea of what is really needed. And hopefully scholarship will follow the boldness of the vision and creativity of the ideas. And so the final thought would be, we welcome your ideas, research agendas, and so forth. NSF is bottoms up. I mean, we pose these challenges to the community, but we at the end depend on the community to come up with aggressive, important, compelling ideas that we can invest public dollars for public good. Thank you very much. Sure, absolutely. I'm happy to answer any questions. Sure. So,
Thank you very much. That was very inspiring, and I'm excited about the idea of learning engineers or health engineers. I mean, if Disney can have Imagineers, we can certainly invent learning engineers and health engineers. So we have a discussant to that presentation. It's Professor Ali Jadbabaie, who's visiting MIT this year from University of Pennsylvania. And interestingly, he is now the head of SSRC, Socio-Technical Systems Research Center, which is the host of this workshop. So we're delighted to have him be here today and be a discussant in response to the wonderful presentation we just heard.
Thank you, Dick. Thank you, Pramod, for a wonderful presentation. I thought I'd start the discussion with a few questions and then open it up to the audience. As you saw, and you saw in Munzer's presentation, we're trying to, and I'm helping him with this through SSRC on the research side and also through this entity on the education side. I think you mentioned the challenge of, well, we know some of the research agendas, you put it aside for us, but there's this inverse problem of how do we train the students to get to do this kind of research? So many of us got here in an idiosyncratic way. We started in control theory, in physics, in systems engineering, and through many years of various events, we ended up working on these type of things, and we realized, okay, we need to bring humans, institutions, technology together. But if we didn't want to spend 15 years to get here, how do you see us, solving the inverse problem? I know inverse problems are always hard, yeah. So.
Well, I think that's an excellent question, and I'm glad you asked, because when I talk about this evolving NSF vision of foundational knowledge, that's really, to me, the goal. The goal is, can we capture this knowledge in ways that can be taught? Clearly, this is not going to be just engineering. It's going to be engineering along with social and behavioral sciences. So the first step would be to begin to build those bridges to people in social and behavioral sciences and domain experts, whether that's cognitive science or, in the case of health, people in the healthcare or health business or health industry, to build those connections and kind of capture that knowledge in a form that can be taught. I think this whole idea of models, which we are very comfortable with in engineering, it may be a language that would take some translation to make sure that the knowledge that's being generated, the questions that are being asked, are some things that we can use. So I think it's a very difficult question. I don't think the answers are clear, But that's the reason why NSF is at the table, is because if we hear from the community that there is potential here and there is a real concrete work to be done, we want to hear that, and that's the purpose of the workshop. So I think what you talked about, Ali, is definitely a significant component of what we want to achieve.
And another question is, assuming that we figure out how to train these students, how do we, I guess, ensure depth in this multidisciplinary thing, that we don't open it up so much that there is not enough depth? That's another concern that I see people have.
Right. So I think that reminds me of a slide that I usually put in one of my presentations, and it talks about the intellectual case for multidisciplinary, you said transdisciplinary. I mean, there are all these words, but I just sort of capture all of them into a single thing called multidisciplinary research. So what's the intellectual case? So the question I pose is the following. Clearly, multidisciplinary research is in vogue, is important. NSF does a lot of it. All the universities I know of try to do it because there is a clear, compelling need from society. So you take the energy problem, the environment, I mean, just go down the list, and I made my own list in my talk. So there is a clear, compelling utilitarian case. But is there an intellectual case? Is there a scholarly case? And the answer, in my opinion, is yes, but we don't pay enough attention to it. And the answer to me lies in the following metaphor of thinking of knowledge as a network. And so control theory is a node, and computer science is a node, and so forth. And some nodes are bigger than other nodes, and you can subdivide them. But you can think of this knowledge as being a set of nodes that are connected to each other. We put tremendous value in academia in going into a node and going deeper and deeper inside that node and dig deeper and deeper. And for that, we get PhDs, and we get journal publications, and we get promoted, and all sorts of rewards follow. What we don't give enough attention and value is in building fat pipes that connect these nodes. So if you think of control theory and mathematics, well, there is a fairly fat pipe there. But is there a fat pipe between control theory and psychology? Probably not. So if we were to give as much value to fattening of these pipes that connect knowledge nodes, I think the world would be much better served. And that's the intellectual case, because you can actually try to organize that knowledge that connects these different domains in systematic and rigorous ways. So if we were to do that, I think we would solve a variety of problems of depth and rigor and all of that, if we were to pay real attention to what constitutes connecting knowledge nodes.
Okay. Could we take one or two questions from the
Sure,
audience?
that's what I was going to say.
Okay, good. So I know we're running a little bit over time, and my fire engine hasn't gone off yet today, but I feel intimidated about pressing the button with such important people here. So, but we do have a time for maybe one or two questions, because we have flexibility at the end in terms of exactly when we start lunch. So I'm not worried about that. Yes, sir.
Chen Chu from University of Arizona. In the daytime, I'm a diligent researcher. In the nighttime, I'm the very frustrating father of teenager too. These days, I found my informal survey among all high school students, I found that when they talk about schoolwork, they are frustrated. But when they start talking about animations, online video games, that's where they really got excited about. And I started thinking about, and I had to start doing my own research, digging into some of the video games. I found out that actually those platforms are fairly complex, have almost all the elements we talk about here. I'm just curious about your thought in terms of, in the future, start to somehow build in those kind of concepts through this kind of gaming platform as part of their education, because very soon these high schoolers is going to be our college students.
So, I mean, NSF actually funds a fair amount of activity in using of games for education. So clearly it's something that we recognize as, instead of thinking of it as a problem, can we turn it into an asset? And people are using that. And I think we go one step beyond. what we want, what NSF is interested in, and we support people who study this, is what is it about gaming that attracts people, students, and helps them, how does learning improve through using it? So to systematize that knowledge about gaming, learning, and human behavior is one of the topics that NSF actually funds research in. So I would say those are just the kind of things we need to be thinking about and working on, not because it feels good or it just seems like a good idea, but because there is actually a knowledge base underneath. And if I look at all the myriad investments that NSF makes in different parts of this puzzle, and just not NSF, I mean, in some other parts, it would be NIH and so forth, there is a lot of knowledge that is not getting connected and used in ways to actually move the needle on the big problems that I posed.
One more question?
Don Norman at UC San Diego. I guess I'm one of the kinds of people you're talking about, because I started off as a course 6 electrical engineer at MIT, a PhD in psychology. I've been a professor of computer science, an executive at Apple, and I've started a new design group at San Diego. Now, design is an interesting field because to design you need to go across all of the disciplines. Design is a crappy field because it's an art, and designers are trained in art schools, and they often hate technology. So we are trying to make it into an evidence-based science, but it's really hard to get people like NSF to take us seriously, because there is a design group, but it's engineering design, and we go across all the disciplines, and that means any given little group at NSF says, well, you know, that isn't what we do. So we really do need to have the work you've done, and your talk was exactly correct. But it's really difficult in today's funding world, because just as universities are divided into silos, so too is NIH and NSF and even DARPA.
I think it's an excellent point. And I would just offer the following response. NSF is us. NSF really reflects the academic community. Panelists are coming from groups like these. They are the ones who pass the judgments of the kind that you talked about. So there is a lot of work that is to be done here to articulate a vision, get it sufficiently shared with academic communities so that we don't have panelists who come in and do the kind of damage that you're talking about. And so I think we need help. I mean, I think NSF, now we tell our program directors to be bold and take risks and so forth. It becomes a lot easier for them if the panelists would come in with more open-mindedness, which is what I talked about. You know, let's not be hidebound by what's worked in automotive engineering as the way to address the kind of questions that we are posing here. But that's going to require your help. This is not going to happen easily. So I can stand up here and talk about what I see as a major opportunity that we have to take take bull by the horns, but we are going to need a lot of help from the academic community because those panelists need to be informed. We are certainly in a position to do some experiments. We take a lot of the programs I talked about, they came out as initial investments from NSF, and we are certainly in a position to do something like that as a seed. But for it to be sustainable, it has to become part of our standard operating process and parts of our various direct divisions and programs. So I would say, NSF ultimately reflects the academic system and all its biases and all its traditions and all its weaknesses, as a matter of fact. So I would.
Well, thank you very much. Let's use that as a challenge to those of us who are academics here in the room, that the next time we're invited to be panelists at NSF, we have these open minds that you're talking about. Thank you very much, both of you.
Well, thank you.